Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with the geometry and the constructions. So remember last lesson what we did was we constructed perpendicular lines. We constructed a perpendicular bisector. We constructed a perpendicular line from a point. So we pretty much covered the various ways we can draw perpendicular lines, okay? Today we're going to look at how can we construct angles and then how can we bisect those angles, meaning divide them in half without using any protractors or measuring tools apart from a compass. Alright guys, so I'm going to take you through these worked examples slowly. We've got to understand how to do it and then we're going to get to exercise 12.1. Okay, so we're going to start with constructing angles on page 108. An angle of any size can be bisected and it is not necessary for the size of the angle to be known. Meaning that I can give you any angle, I can just draw an angle on the board and I say, right, bisect this angle. You don't need to know how big it is, just do it. Okay, so example, or rather the worked example on page 109 at the bottom says bisect angle ABC without measuring the angle and then check your accuracy with the protractor. Now guys, in tests and exams, you might be tempted to cheat because you'll have your protractor there, but without the little arcs where I can see you've put your needle compass and you've made an arc and that's where your measurement is, without that, I'm not going to give you any marks because I understand you could have just measured it with your compass and drawn the line in. So I want to see all those arcs and all the construction points. All right, so let's start. First, we need to draw an angle ABC. Okay, let's see which pen works. No. Okay, that's better. All right, so we need an angle ABC. So we're going to kind of do it like on the board in the textbook. So there's our two lines that are doing that. Okay, so that is line ABC. So that's A, B, B is that point there, and that is C. Okay, we have an angle ABC. Now what we need to do is we need to bisect it, meaning we need to cut it in half like that, so that the two angles are exactly the same. All right, so what we're going to do is first place the sharp point of the compass on point B and draw an arc from line BA to the line BC. So what we're doing is we're placing our compass point here. We're opening up the compass and we're making an arc like that. Okay, so we just make an arc and after that we take out our compass. Now we place it into these 2 points over here. So on the drawing they've labeled them D and E. Okay, so that is D and E. Step 2, from D and E construct 2 more arcs of equal length and label their point of intersection F. Okay, so again, now we set our compass needle point at D. We open up our compass to, nothing small. It's got to be about 3/4 of this arc. Okay, maybe even bigger. So put your needle point here and make an arc like that. Okay, now you're going to keep that same distance and you're going to put the needle point at E. Keeping the same distance, you're going to make another arc like that. Okay, so again, I'll repeat. So starting point, you're going to place your needle point at B. You're going to make one arc across the 2 lines that we have, or the 2 arms of the angle. Okay, you're going to label these points D and E. Okay, we're labeling them for the sake of reference in this example, but if you're drawing them, you obviously don't always have to label them. It's just construction lines. Okay, but here we label them so that I can explain which sections we are doing. So once we've drawn this arc, we take our compass point, put it in D, open it up some distance so that you can make an arc in between over here. You're going to keep that distance, put the needle point at E, and make another arc over there. All right. Once you are done with that, you're going to take your ruler and you're going to join the line where the angle starts and the intersection between the 2 arcs. Okay, guys, my lines are a little bit skew. I don't have a big ruler. Maybe I'll get one soon. But you guys need to have straight lines. Okay, so now this is a bisected angle. So we've bisected angle ABC into angle AB. What do they call that point? F. ABF and FBC. Okay, and now we can bisect this angle again and again and again. So basically, if we can find a particular angle, we can always divide it in two and find another angle without actually measuring what the angle is. Okay, in the next section, I'll show you how to actually get a particular angle, say angle of 60 degrees, and then from that angle, we can bisect it until we get the required angle, or, well, it depends what the question is. All right, guys, so step 4, what they're saying now is check your angles. Okay, so in this example, they didn't tell us what size angle to make this big one, right? So you could have made it whatever it is. But now take your protractor and measure this angle here and measure that angle there and see if they are the same angle and see how accurate you have been with your tools. Okay. So here visually they're not the same, but I don't have rulers to make accurate lines. Okay, guys. So let's continue. The next section says constructing angles without a protractor. An angle of 45 degrees can be constructed in 3 different ways. Okay. Well, think about, where does 45 come from? It comes from a 90 being cut in half. Well, we've just learned how to bisect an angle. An angle of 90 degrees would be bisected in exactly the same way. Follow the procedure. Draw an arc, go to that arc, and draw another 2 arcs. So we could get a 45-degree angle by bisecting a 90-degree angle, or by constructing a right-angled isosceles triangle. Okay, a right-angled isosceles triangle looks like that. It's one of the set squares in your geometry kit. Okay, remember it looks like this. So that's 45, that's 45, that is 90. Okay, so we could construct a right angle triangle with the same distance sides, and that will give us the same angle, which is 45 degrees. Okay, and by constructing an angle of 60 degrees and then bisecting it. Now bisect one of the 30 angles to obtain an angle of 15. Finally, add the 30-degree angle and 15-degree angle, which are adjacent to each other. Okay, what they're saying there is they're saying that, well, we can start off with a 60-degree angle like that, and I'll show you how to get a 60-degree angle. We could bisect that 60 into a 30 and a 30, and then we can bisect this into a 15 and 15. So the first angle is 30, the next one is 15. If you add them together, that will give you an angle of 45. So a good question for this section, I could say, construct an angle of 45, 60, and 15 degrees without using your protractor. And this is how you would do it. Okay, I'll show you exactly how to construct an angle of 60 degrees. Well, we've got one way, but there is another way. Right, an angle of 60 degrees can be constructed by using equal arcs, as shown in the next worked example. By adding 45 degrees and 60 degrees, you can construct an angle of 105. If you bisect the angle of 105, you get 2 equal angles of 52.5. Adding 45 and 52.5 gives an angle of 97.5. All right, guys, so basically what they're just trying to say is that we can really get into details of bisecting different angles and getting different pieces and then adding those pieces together to get whatever angle we want. Okay, 15 degrees is obtained by bisecting 60-degree angle to obtain an angle of 30, and then bisecting that 30-degree angle again to get an angle of 15. A 330-degree angle is obtained by constructing an angle of 60, then bisecting it to obtain an angle of 30. The reflex angle is 330. So what they're saying to us is that we can have an angle of 60, which we'll know how to do just now. To get an angle of 330, we know that the full revolution is 360, and that adds up to the acute angle and the reflex angle. So if we start off with 60, we can bisect it into 30 and 30, right? And then this reflex angle there is going to be 330 degrees. Okay. Right, guys, so you don't need to exactly memorize all of these. We're going to work through the different examples and you're going to learn from practice how to actually do this. But remember, the most important thing here is knowing how to bisect an angle. Then you can use the different pieces to add it up. All right, guys, let's get into that worked example. So we are on page 110 in the yellow section. All right, so it says 1. Construct ABC which equals to 60 degrees. Okay, they've forgot the little copy on the B. Do you see that? In my textbook, there's no copy, so you can put it there. It should be construct ABC, which is 60 degrees. So the angle is at point B. All right, so guys, this is how we're going to do it. Step 1, we're going to draw line BC. Okay, let me just erase this. So remember, we want to construct an angle of 60 degrees, which is angle ABC. So ABC. So what I'm going to draw is I'm going to draw line BC. Okay, there's my line BC. Right, the distance of the line doesn't matter because we were given that we need to make a 60-degree angle, not a 5 centimeter line. So we draw a particular BC. Now what you're going to do is you're going to put your compass point at B, stretch it out to C, and you're going to make an arc like that. Okay. Right. Now what you're going to do is you're going to swap and put your point at C, open it up to B, so keep it at the same distance BC. So put your needle point there, and you're going to make another arc like that. Okay. I'll make them darker so you can see them, but you guys must make them faint so they're construction lines. So they're visible, but they're not as dark as your main drawing. So the main drawing needs to be in dark lines, and construction lines can be around it. Okay. So we've done this. Okay. Now what we're going to do is we're going to join this B through the cross that we have over there. Okay. So this point now is going to be point A. All right. So now we've really constructed a 60-degree angle. Why? Well, let's think about it, right? Which triangle has 60-degree angles everywhere? It's an equilateral triangle. Is that not what we have over here? Well, think about it. If this is a point over here, how did we get that distance and that distance? Well, we opened up our compass to BC and we marked off there. We opened it up to BC again, marked it off there. So what that's really telling us is that this triangle, if we join that point to that point, is going to be an equilateral triangle, which means that there'll be 60 degrees here, 60 there, and 60 there. But they didn't ask us to draw an equilateral triangle, they just asked us to draw an angle of 60 degrees. But really, it's just one line away from having an equilateral triangle. So this here is our 60-degree angle. Okay, and then from this, we can bisect this angle, bisect that angle, and carry on bisecting to get different sizes, angles, depending on what I'm asking you. Okay. Right, let's now try to bisect this and see what we get. Number 2 says ABC equals to 60 degrees. That's what we have. With BD, so that DBC equals to 30 degrees. So we have DBC equaling to 30 degrees. So if this ABC is 60, they want a D somewhere here, so that DBC is now 30 degrees. Well, 30 is a half of 60, so we have to bisect this angle. Okay, how do we bisect an angle? Well, we place our compass point at B. We open it up to the point of intersection there. Okay, we keep that distance there, right? Then what you're going to do is you're going to put that needle compass into this point over here, and you're going to make an arc over there. You're going to do the same thing. You're going to put the needle point at C, keeping the same distance as before, and we're going to make another arc over there. Okay. There's a glare there, so I'll bring it a bit closer. So it should be something like this and like that. Okay. Hope you can see that. Yeah. And then what we're going to do is we're going to join this line through the intersection, and we're going to call that point D. Okay. Right, so we've bisected the angle of 60, so this is now 30 degrees and 30 degrees. Okay. Right, let's continue. Number B says DBC equals to 30 with BE so that EBC equals to 15. So they want EBC to equal to 15. Well, we're going to do exactly the same procedure as before. Here we have an angle. We need to bisect it. What are we going to do is we're going to put our needle compass point here. We can open it up to C. We can open up a little bit shorter if you want to. It doesn't actually matter. So we're going to open up our compass, keeping that distance. We're going to make a mark here and a mark there. Okay. Then we're going to keep the same distance. We're going to place that compass point into here, make an arc there. Place that compass point here, make an arc there. Okay, exactly the same procedure as we had before. Now we're going to have this intersection there. We're going to draw this line that bisects this angle through the intersection, and we're going to call that point E. Now this angle was 30, which means this is now 15 degrees. Okay, and that is also 15 degrees. All right. Guys, that's how we bisect angles. The next part, C, says again, bisect 15 into 7.5 and 7.5. So it's exactly the same procedure. We mark off some distance over there, place our compass point here, open it to another distance, make a mark there. Do the same procedure, put your compass point here, keeping the same distance, make another mark. Then we join that line through that line, and we have 7.5 degrees, 7.5 degrees. Now, let's say the question says, okay, show me an angle of 45 degrees. Which angle is 45 degrees? Well, let's think. The whole angle is 60. Then we cut it in half first. We got a 30. We cut the other 30 in half again, and we got 15. So if I want an angle of 45, I say, name the angle that is 45 in this drawing or in this diagram. Well, it would be A, B, and E, because that's 30 plus 15, which makes us 45. Or I could ask for another angle or some, the combination of these numbers. You just need to pick the right one. Okay. All right, guys, so that's number 2. Number 3, name an angle equal, well, there we go. There's the question I was talking about. Name the angle equal to 22.5 degrees, an angle equal to 45, and an angle equal to 52.5. Okay, guys, again, it's combinations of these angles. 22.5 is made up of, remember, the options are not limitless here. There's only 7.5, 15, 30, and 60 to work with. So those are the only combinations. So to make an angle of 22.5, I need a 15 and a 7.5. Those two will add up to 22.5. So which angle is that? Well, it's DBE. Okay. They have DBF. Let's see. DB. Yes, sorry, not DBE. This is F over here. That's E. So it's DBF. And then angle of 45 we just did. That's the 30 and 15. And the angle of 52.5. Okay, 52.5. Well, we already have 45 here. If we add another 7.5, we're going to get exactly what we need, which is 52.5. Okay, so that is this angle here, which is ABF. Okay, is that what they have? Yes, they got angle ABF. Alright guys, that is how we're doing constructions of angles. This is a very important section because if you can construct angles and perpendicular bisectors, you can pretty much do most of the things in geometry. Okay, we'll obviously do a bit more constructions later on, which looks at how do we construct triangles with different lengths. And yeah, we'll get onto that in the next lesson. Okay guys, I hope you enjoyed it. I want you to do exercise 12.1 for homework. Okay, 12.1 is for homework, and I will continue on the next page with triangles in the next lesson. Thanks for listening. I hope you enjoyed it, and I'll see you guys in the next lesson. Bye.